Previous video, we saw how a naive program to update the database can cause problems. We found that this program here that we were using led to problems. The idea is that it finds out how much money is in one account, finds out how much money is in the other account, and then updates both of those accounts, transferring a value from one to the other. And we found that if we ran two copies of this program at the same time, they'd interfere with each other. In particular, what could happen is that in between reading to find out how much money A's got and how much money B's got, and updating it to transfer money from A to B, we discovered that another process could have got in and updated that value, which meant that not only did not all the transactions complete, but sometimes we would actually end up creating or removing money from the system as a whole. And we try and fix that with the new version. So this version is trying to do exactly the same thing, but there's some changes. We've got an update statement here. We've got a begin transaction statement. So before we do any SQL queries, we begin a transaction, and when we've completed, we issue the commit. And the idea is that by bracketing our SQL statements between the begin transaction and the commit, we can at least detect if something goes wrong. So the first change then is to start transaction here and end, and commit when we get to the end, but we also check the result of every one of our execute statements. So there are four places at which we are updating the database or interacting with the database, reading or writing. We've got two reads here, so this is a read and this is a read. So the two select statements have got reads, and we check to see if they succeeded. So the call to execute will either succeed or fail. If it succeeds, then this STH execute line will return true, and we can continue processing. If it didn't work, then it'll return false, and we'll hit one of these die statements, which basically outputs an error message and prevents the program from doing any more processing. So every one of the interactions, every one of these execute statements has been put in the test, so we can tell if something has gone wrong or not. And if something has gone wrong, then typically we'll roll back, we'll give the error message, and no more processing will happen. Let's find out what happens when we run these. So our program is very similar to as it was before, and it operates in the same kind of way. We can run this program. So this one is called TRWT. So this is transfer with transaction. We can transfer £1 from Andrew to Brian. Let's just check, see what's going on in the database. So if we log into the database and check that it's £100 in each one. So just as before, I can transfer £1 from Andrew to Brian, and as we expect, things get updated. So that's Andrew's £1 poorer, Brian's £1 richer. Let's put the money back again. So we're transferring minus £1 from Andrew to Brian, and things are back the way they are. We can do it once, we can do it 100 times. So let's have a go at doing this 100 times, and we'll see if we can do it 100 times in both windows. So here's my loop. This is a bash loop, and in the top window, we're going to transfer money one way. In the bottom window, we'll transfer money the other way. Let's just put that in. So in the top window, we're transferring £1 from Andrew to Brian 100 times. In the bottom window, let's transfer minus £1. So minus 1 going from Andrew to Brian. So if this succeeds, we should have £100 going in, £100 going out. We should end up equal at the end. Let's see what happens. So start that one, start this one. They're both going. I don't know if you noticed that, but in the bottom window, we had some error messages coming up. We can see that when the second window is finished, that's not looking good. It looks like the money isn't even. We haven't actually gained or lost money as we did last time. Andrew's got 98, Brian's got 102, and it looks as if there were two failures. I'm just scrolling back here. Can we see? There are two occasions where the update failed. So this update failed, and this update failed. And these were both attempts to send minus £1 from Andrew to Brian. And because that happened twice, that explains why Andrew is £2 down on the deal and Brian's got £2 more. So we haven't prevented the error from happening, but at least we can detect it. And in practice, when you're running transactions like this, you expect them sometimes to fail, and you need to have some kind of mechanism to cope with that failure. In this case, we just outputted an error message, but you can see that this is the transaction that was attempted. This is one transaction that failed, this is another transaction that failed, and one of the options we've got is to just rerun those just keep trying those transactions until eventually they go through. The important thing that we've achieved over the last one is that it is no longer possible for us to either create or destroy money in this system. The transfer from one to the other either completes completely or it completely fails, and it can't half complete and leave us in an inconsistent state.